All right, today we're going to tackle a topic that's honestly foundational for every single future physician. How does AI actually learn? Now, don't worry, you're not going to need to know how to code or anything like that. But what you do need to understand are the core principles behind these tools, because trust me, they are going to shape your career. So let's dive right in.
So, let's just start with the big question, the one that's going to guide us through this whole explainer. How on earth does a machine learn like a medical student? I know, it sounds a little strange, right? But the process is, well, it's surprisingly similar. And by using this analogy, we're going to break down a really complex topic into something that just makes sense.
Okay, so here's our game plan. First, we'll talk about what learning even means for AI. Then, we'll use a board exam analogy, you like this one, to see how they're tested. We'll get into the huge difference between memorizing and truly understanding something. Then we'll cover the really serious topic of hidden bias. And finally, we'll wrap up with what's probably the most important piece of the puzzle, your role as the physician.
All right, first up, what does it actually mean for an AI to learn? I mean, it's not like it's pulling all-nighters with a pot of coffee, right? But it is a process of exposure, making mistakes, and then refining things. You know, a process you're about to get very, very familiar with. So the fancy term for this is machine learning. And the key difference is this. With old-school software, a programmer has to write out every single rule. You know, if this happens, then do that. But with machine learning, the system pretty much learns the rules all on its own. It just gets exposed to a whole lot of data, starts looking for patterns, and basically improves itself through experience.
And this is where that medical student analogy really clicks. Think about it. You learn from textbooks, from patient cases, from your clinical experience. Well, an AI does pretty much the same thing. It's just that its textbooks are these gigantic data sets. We're talking thousands upon thousands of x-rays, millions of lab values, endless clinical notes. It's all about pattern recognition, just on a scale we can barely imagine.
Okay, so the most common way this happens is something called supervised learning. It's actually a pretty simple four-step loop. Let's walk through it. Step 1, you feed the AI labeled data. So for example, you give it an x-ray that a top radiologist has already marked up as pneumonia. Step 2, the model takes a guess. It says, I think this is pneumonia. Step 3, you compare its guess to the real answer. And step 4, and this is the key part, if it was wrong, it actually adjusts its own internal wiring to do better next time. Now, imagine doing that 1,000,000 times over. You end up with a model that gets really, really good at spotting pneumonia.
So, if that's how it learns, how do we actually test an AI to know if it's any good? Well, just think of it like your board exams. You wouldn't be tested on the exact same questions you saw in your practice tests, right? Of course not. It's the same for an AI. It absolutely has to be evaluated on data it has never, ever seen before. This is, and I can't stress this enough, absolutely crucial for making sure it's safe and reliable for patients.
And here's a great way to visualize how that's done. The data gets split into 3 separate buckets. First, you have the training set. Just think of this as all your lectures and textbooks. It's where the AI does all its foundational learning. Next is the validation set. This is like doing practice questions. It's how we fine-tune the model and make sure it's on the right track. And then finally, we have the test set. This is it. This is the final board exam. It's completely new material that gives us a real unbiased grade on how well this AI is actually going to perform out in the real world.
You know, this whole testing process brings up a really critical point. It's a trap that honestly gets both medical students and algorithms. And that's the difference between just memorizing the answers versus actually understanding the concepts underneath. In the world of machine learning, they have a name for this. It's called overfitting. It's basically when a model looks like a genius on all its training data, gets a perfect score, but then completely bombs the final exam. So why does that happen? Well, it's because it didn't actually learn the general patterns of a disease. It just memorized the specific examples it was shown, right down to all the random noise and unimportant details.
So the goal, the absolute bottom line, is that we need models that can generalize. That means they learn the real underlying patterns of a disease so they actually work on new patients and are clinically reliable. An overfit model isn't just bad, it's dangerous. It's going to fail in the real world. And what's even worse is that it can give you this false confidence in a tool that is just broken.
And there's a sneaky cousin to overfitting called shortcut learning. This is when the AI gets the right answer, but for a totally wrong reason. For instance, imagine it learns to associate pneumonia with x-rays taken with a certain portable machine. Not because it sees the pathology in the lungs, but because it recognizes a tiny watermark that machine puts on every image. Or, get this, it might learn that a picture of skin cancer often has a ruler in it, so it starts looking for rulers, not melanoma. It's a clever trick for sure, but it is absolutely not medicine.
Okay, we need to talk about something incredibly important now. Maybe one of the most important topics in this entire field, and that's the danger of hidden bias. Here's the thing, an AI model only learns from the data we give it. And if that data carries the baggage of our own history, including inequities in healthcare, well, the AI is going to learn those biases too.
This is really the core idea you need to grasp. If you train a model mostly on data from, say, one demographic group, it might just not work well, or worse, it could be unsafe for other groups. Any gaps, any inequities that are in that original data, they get baked right into the model's brain. And that doesn't just replicate our existing health disparities. It can actually make them bigger.
Just look at this. This quote is from a huge landmark study. They found a widely used algorithm that was systematically less likely to refer Black patients for extra care, even when they were just as sick as white patients. So what went wrong? The algorithm was using healthcare costs as a stand-in for how sick someone was. But because of systemic issues, Black patients often had lower healthcare costs for the same illness, so the AI thought they were healthier. The researchers found that fixing that one single biased assumption would have more than doubled the number of Black patients getting the critical care they needed. This isn't just a technical problem. This is literally a life and death issue.
And that is why you, as future clinicians, have to become skeptics. You have to be critical evaluators of these tools. You need to be asking these questions always. Hey, what data was this thing trained on? Does that data actually represent the patients I'm seeing in my clinic? Was it even tested to make sure it works fairly for everyone? Is this a tool that can be used anywhere, or does it only work at the one fancy hospital where they built it? These are your responsibilities.
Okay, all of this leads us to our final and, honestly, most important point. In a world full of AI tools, what's your role as the physician? The answer is actually pretty simple. Your judgment, your expertise, is more critical than it has ever been.
This is a distinction you absolutely have to remember. An AI tool does not diagnose a patient. It predicts a probability. It might spit out a number like, there's a 38% risk of this patient developing sepsis in the next 6 hours. Now that's a powerful piece of information, right? You can think of it like a new kind of vital sign. But it is not a final decision. It is just another piece of data for you, the expert, to interpret.
At the end of the day, AI is a tool. A ridiculously powerful one, yeah, but it's still just a tool in your bag. The ultimate responsibility, both professionally and ethically, for every single clinical decision that still rests squarely on your shoulders. You're the one who takes that AI prediction and you combine it with everything else you know about that human being in front of you, their history, what they value, your physical exam, and then you make the call. Okay, so let's wrap this up with the key takeaways. Number 1. AI learns by finding patterns in massive amounts of data. 2. Splitting data up into train, validation, and test sets is non-negotiable for making a reliable tool. 3. Overfitting is just memorizing, not real learning, and that's a big problem. 4. Biased data will always create biased AI, and that's a huge patient safety risk. And number 5, the big one. AI predicts, but you decide. Your clinical judgment is and always will be the most important tool you have.
And that really brings us to the final thought I want to leave you with. Look, AI isn't some simple yes or no thing. It's an incredibly powerful new tool that's going to be a part of your daily life as a doctor. So the real question isn't if you'll use it, but how. The question for you is, how will you, as a physician, decide when to trust it and when not to? Because your ability to answer that question, well, that's what's going to define the future of medicine.